So Dave, what are we looking at?
So this is our Moldflow software that we use to analyze and predict what is going to happen to a plastic part when we injection mold it. It looks at warp, it looks at fiber orientation of the plastic if it has a fiber in it. It is basically like an FEA. It really doesn't do a lot with strength, but it will predict warp very well. And then, can we fill the part? Where are we going to gate the part at?
This will tell you where to gate? Really?
Yes, it'll give us a suggestion of, okay, these might be the best areas to gate, and then it's really up to the operator, the designer of the injection mold. One, from experience of saying, okay, well, one, because of the style of machine we're going to use, the mold base we're going to use, may have some things that lock us into, okay, we have to gate in maybe a couple options that we have. So they'll decide which is the best option, depending on what mold base we're using, the materials and all that kind of stuff, to figure out where to place that gate at. And we want to make it as simple as possible for gate removal at the end. You know, sometimes we have to machine the gates off. Well, that gets expensive because you have to build a fixture and all this other stuff. So if we can do it with, you know, a set of clippers or a file or a razor blade to take a gate off or just breaking it off, then that's what we do. This particular part is an overmolded part. So there are metal brackets and terminals that get overmolded inside of that thing.
I see a lot of red. Is that because it's
so that
cooling down
that's the fill time. Okay, so what that means is that's the last section of the part to fill as the plastic's going through it. And you can simulate the plastic flow, right? Yeah. So it's being gated in the bottom there, and it kind of falls up. So what we try to do is make the filling as even as possible. So we want, you know, the last part on this side and this side of the part to fill at the same time. That way it reduces warp. We know if we have, you know, one hot spot that's the last corner to fill, or, you know, it may not fill, may gas up, may have some issues with filling. So we're able to change things around, and then also look at the process. You know, what injection pressures are we using? How much heat, our water lines, you know, we may have to change water or hot oil depending on what we're doing. Have to change that around to get better cooling on the part. You know, if we know we have a spot that is getting, let's say very hot at the end of the fill or something, because typically the end of the fill is a little bit hotter. And would, you know, likes to burn and from the gas and things like that are inside the mold. So we can also analyze venting because you have to get the gases and the air and all that stuff out of the mold as that plastic's coming in, because this will be filled in just a second, right? And it's completely filled, and then you just go into the packing stage. Well, we can adjust all those settings up here, and then all that information is given to the injection mold operators, the setup guys, to process the part.
Cool. So when you were talking about the gates, it tells you where to put them. Does it tell you how much volume is going to come through each one of the gates, or anything like that, so that you
No, not really. But, you know, there's some standard practices on gating. You know, runner systems and gating, and the plastic suppliers, you know, let us know what the flash point of the material is. So it might be 1,000ths, it might be half a thousandths, it might be 2,000ths before the plastic actually starts flashing, because we need to know that when we design our vents, so that we're not squirting plastic into the air vents and plugging those up and then having to trim those off the part.
And flashing is, I'll let you describe it, but flashing is something that you really don't want, and it usually is around the outside edges.
It's around the perimeter where the two halves of the mold come together. And that's where choosing the right size press, enough tonnage to hold the tool closed, because the mold machines are rated on clamp tonnage, but they have to hold back the forces that you're putting into that mold. So this also tells us, you know, what the tonnage is, what size press we need, and then we can pick from there. Okay, we know what press is going to go into. We can start kind of picking out which mold base we might use to fit into that press. We have a library of just mold base after mold base. We build them out of aluminum. We build them out of steel, P20, 4140, stainless steel,
Still
different
use
materials like
Kirkzite?
that, heat-treated materials.
Yeah. Do they still make molds out of Kirkzite, or has that been kind of put aside?
I haven't seen a Kirkzite mold in
Neither
a
have I.
very long time. When I
Yeah.
first started doing this 30 years ago,
Yeah.
we attempted some Kirkzite molds, but they're not very stable. They always
No.
have porosity.
But everybody.
For a stamping tool, it's
Yeah.
not a bad thing because it doesn't
Yeah.
really a little missing void in the material is not going to really hurt anything on the stamping.
Yeah.
But an injection mold is going to fill that with plastic. So.
Right. Yeah.
And they're very difficult to weld and things like that to
Oh, they're
repair
next to impossible.
Kirkzite.
Yeah. I just remembered that when I was a kid, they were everybody was on them, and on the floor. If you're a toolmaker, that wasn't what you wanted to
Right,
see.
right.
I didn't want.
You know,
to,
and now with some of these materials, especially the aluminums,
Yeah.
we can get very big blocks of high strength aircraft grade aluminum.
Yeah.
You know, that's B90 right at the beginning of the C scale
Yeah.
of how hard it is, all the way through a block that's 20 inches thick.
Yeah.
So you
wow.
can actually cut some nice material now compared to what we had. Like I said,
Eons
30 years
ago,
ago,
yeah.
we're using a softer material like a 6061 or
Yeah.
something like that.
Well, you used to be able to get 7000 series aluminum, but you were taking it away from building spars for airplanes and stuff like that.
Right,
And
right,
it was just faster, and it all had to be forged as well because nobody was going to.
right. So there's a lot more
Yeah.
companies doing that now. Mills making aluminum
Right.
that make these high grade, big,
Yeah.
thick blocks. And they
Perfect.
stress relieve them, they stretch them, and they do all kinds of stuff to make sure that hardness is even all the way through.
Yeah.
Especially if we're cutting let's say an injection mold for a headlamp lens.
Yeah.
Your cavity is in the middle of the block of aluminum, right?
Right.
So if it's softer, it's not going to polish the same.
Right.
It's just not good when you're doing, especially
Yeah.
lens work and things like that.
Right. Oh, this is way cool. Well, let's go down and look at. You got this. Let's see where they put them all together and make these things. Yeah.
Sounds good.
Good. How do we get out? Oh, here.